Good morning and welcome. I am Sam Spencer. I'm here with Benjamin, and we're going to talk about proxying with YARP. So let's start with what is a reverse proxy? Well, there are two kinds of proxy server that you may be familiar with. There's a forward proxy, which you might be familiar with from school or work environments, and those are used to send HTTP traffic out from a firewalled environment, such as a school or a business, to the internet. A reverse proxy is effectively the reverse. It is used for managing traffic from the internet coming into a data center of some form. Typically, you'll deploy a reverse proxy behind the firewall, and the firewall will only allow HTTP traffic to the reverse proxy. It doesn't get to see any of the backend traffic. So the reverse proxy is kind of the gateway, the controller, the router for HTTP traffic coming into a suite of servers. So the reverse proxy controls the URL space and brings in requests and then forwards them to backend servers. Those don't have to have a direct URL mapping to what was on the incoming request. And it can load balance across those and sends the responses back, proxies the responses back out to the internet. Just about every site that you use on the internet will be accessed via reverse proxy. It's completely transparent to you. You don't really know about it. The other thing, once you have a reverse proxy in place, is you can offload work from your backend servers onto the reverse proxy. For instance, quite common to do a TLS termination at the reverse proxy and then just do plain text HTTP to your backend servers. Similarly, you can do authentication, authorization, compression, caching if necessary. Static file sharing can also be done from the reverse proxy. There's a lot of opportunity there when you can intercept the HTTP stream and do what you need kind of in between the backend and the internet. So we talked about a couple of these of why to use a reverse proxy. Load balancing is a typical example. You have multiple servers at the backend, and based on the incoming request and logic within inside the proxy, you decide which of those backend servers to handle the requests. As part of that, you can use health checks, both active and passive, to determine which of those backend servers are healthy, which have the most load, and choose your load balancing based on that health status. Another common thing is doing indirection between the URL space that customers see publicly and how that's implemented at the back end. For instance, you may have a /customers URL, but in the end, the back end, that's going to a different site, a different server named customers.whatever. And the URL can be transformed as it goes through the reverse proxy. It allows you enables you to do like API management, so you can chain if you're migrating, you can use the reverse proxy to morph from one API kind of shape or surface to another. We talked about offloading. A/B testing is another common feature. So you have two instances of your site. One is the kind of known stable version, and a second is kind of the new one that you want to test. And you can direct just a small portion of the traffic to that new one, verify everything works, and then ramp up that load over time. In a Kubernetes environment or service fabric, you typically use a reverse proxy for ingress control, which is deciding which of your nodes and pods to send traffic to. Another example we are using in .NET is .NET Framework migration to .NET Core. You run the reverse proxy on the .NET Core server together with new functionality, but for any pages that haven't been migrated yet, you use YARP to forward those to the old .NET Framework server. So lots of opportunities with reverse proxying to manage how your HTTP traffic is used. So YARP, strange name. It's for yet another reverse proxy. There's kind of an internet meme, maybe it was memes before internet, of calling something yet another. So Yak, for instance, is yet another compiler, which is a compiler code generator. So how is YARP different from a number of other reverse proxies out there? Well, we built YARP because we had internal teams asking for functionality that they couldn't get from existing proxies. What they wanted to be able to do was customize to a much higher degree without having to delve into the code of those reverse proxies and actually modify it themselves. And so What we've done with YARP is kind of invert the customization and proxy logic. So we actually supply YARP as a library rather than as a pre-built exe. And you then incorporate YARP in with a standard ASP.NET configuration, and it then forms a proxy. But you can use other ASP.NET middleware. You can use it in conjunction with API endpoints, Blazor, anything else in ASP.NET at the same time. But this also enables you to extend YARP, and we have made YARP, and we'll go through that in the process of this talk. We've made YARP really extensible. So just about everything that YARP does is customizable and replaceable. So we've had 3 releases of YARP so far. We're about to release a new one. Probably it may even hit between the time that we're recording this talk and it goes live. We're written in C#. We have a very layered approach. We are written as ASP.NET middleware. The resulting proxy built with YARP is fully cross-platform. We'll work on Windows and Linux. We work very happily in a container. We work on ARM64, x86, x64, wherever you want to run us. We have really great performance. We're comparable to Nginx and Envoy in most scenarios and perform better than them in certain ones. Because we're based on ASP.NET and HTTP client, we have adopted the latest protocols, and we're using YARP internally to drive features into those platforms. So we have support for gRPC, HTTP2, HTTP3, WebSockets over HTTP2. As new functionality becomes available or new standards become available, we add them to ASP.NET Core or HTTP client, and then they become available in YARP. And so we built YARP because we had internal teams who needed it, but we also then realized from a .NET team that this is a really great scenario to drive improvements, particularly around performance of like end-to-end, because it uses our whole networking stack. So we use YARP as an internal test bed to ensure that our platform can meet the needs of both internal and external customers. YARP is used by a number of internal teams and external customers, such as yourselves. 2 examples that we like to tout. I'll start with Dynamics 365. They were one of the teams that came to us, working at the networking team, and said, "Hey, can we have these features in HTTP client?" And we're like, "Why do you want those?" "Well, we're trying to build a proxy." It's like, oh. So YARP is actually derived from work that Dynamics 365 started. They had their own version of it. We took that, we forked it, we added a lot more resilience to it, brought it to the .NET coding standards, etc. And subsequently, Dynamics 365 has picked up YARP. So they started on .NET Core 3.1 and subsequently have moved to .NET 6 and .NET 7. And they're getting billions of requests a month. They have it deployed on over 1,500 instances, and they're getting a 7.9 success rate. It's incredible. Another example, which is a really more interesting one, is Azure App Service. So that is the website hosting service in Azure. And they have both a Windows solution and a Linux solution. What they wanted to use with YARP is they had a different proxy for both of those. By moving to YARP, they could replace IIS and ARR that was aging, and Nginx that wasn't quite meeting their needs around customizability. And so they could have one proxy to serve in a unified code base both their Windows and Linux solutions. In the process of moving to YARP, they got a significant performance improvement, lower CPU usage, and enabled a bunch of extra scenarios. So HTTP2 to enable gRPC was really important to them. They now support HTTP3, a lot of customization around TLS and control there over certificates for particular sites. The reason why one of the big reasons why Dynamics wants to use YARP, sorry, not Dynamics, App Service wants to use YARP is typical configuration doesn't scale to their requirements. They have millions of sites, and so when traffic comes in, they don't have all that configuration stored on each individual server. They have a cache of information and use that to know what the appropriate backends are. If that cache doesn't have the information for the particular request coming in or the site that it's being requested for, they will go to their backends, figure out that data, pull it into YARP, dynamically add that to their cache, and then route the requests. So it's a really dynamic solution that they couldn't accomplish with a traditional proxy. So that's kind of some background to YARP. I'm going to switch over to Benjamin to show YARP in practice.
Hi, everyone. So in this demo, I will show you how to create a very basic YARP instance. Basically, we will build a reverse proxy for two APIs that are running locally on my machine for this demo. So on the port 5001, I have an API that always return blue. And on 5002, I have an API that always return red. You can see here also that I'm dumping some HTTP the HTTP request that the API received, so we can dig into it later. So let's get started. So we will build a very simple web project like that. It's a bit slow, sorry. Okay, let's go here. So the first step is we need to install the YARP package. Let's start with that. Add a reference to the NuGet package. So here I am referencing to the next version 2.10. And then we need to replace our program to use effectively YARP. And by the magic of copy paste, here is the code. So let me explain. First, we just create a builder. Then we add the reverse proxy components to our services. Then we say, okay, now you need to load the config from the app settings JSON file. So put in standard stuff. We build it, we map the reverse proxy, and we run it. Pretty simple, but let's dig into the configuration now. The config is pretty simple. So what's important here is the reverse proxy section. In this part, we have two different subsections, one called routes and one called clusters. So in the routes one, we will describe and configure all the routes that we want to proxy. So for example, in this example, I only have one route that is basically a catch-all, and every request will be proxied to cluster one. And of course, it's in the cluster subsection that we define our cluster. So here I only have one cluster called cluster one that have two different destinations, one blue and one red. So with this simple configuration, YARP should be able to load balance between those two APIs, basically. So let's save it. Now run it. Building. It's always a bit slow. Yep, okay. So now if I open this web page, okay, I can see here I'm hitting blue. And if I hit F5, now I hit red. And yeah, you see it's changing. Sometimes it's blue, sometimes it's red. Okay, that's great, but it was a bit too simple for an example. So let's dig into the configuration. Let's say I want to redirect, well, to proxy all the traffic with the URL /red to the red cluster and /blue to the blue cluster. We can do that by just changing the configuration. And you can see here in this new config, I have two different routes, the blue route and the red route. When the path is /blue, please use the blue cluster. When the path is /red, please use the red cluster. And we can see here now I have two different clusters, the blue cluster that will target the blue API and the red cluster that will target the red API. Let's save this config file. And an interesting thing to see is that we don't have to rebuild or redeploy our app. We just change the app settings, and YARP detected that it needed to be reloaded. So let's go back here. And now if I hit this URL, I should always get blue. And now if I hit this URI, I should always hit red. That's it. That was that simple to build a very simple reverse proxy using YARP.
Great, that's fantastic, Ben. So let's talk a bit more about the YARP architecture. So YARP is based on ASP.NET Core for its front end and HTTP client for its back end. As Ben showed, we work from configuration, and there are multiple configuration sources that you can use. The default is to use app-settings.json. From that, we have the set of routes, and we will load those routes into the ASP.NET routing table. YARP is just middleware that fits into ASP.NET like other middleware. So you can mix it with API calls or other middleware as you need to. When a request comes in that matches that route, YARP will, ASP.NET will call into YARP saying, here's the route, here's the HTTP context that's used. And the first thing that YARP does is map from that route to what is the cluster, and therefore what is the potential set of destinations for that request. Another feature of YARP is health checks. We support both active and passive health checks. Active health checks is through configuration, you tell YARP what URL to go request on the server and the frequency and how many failures, etc., are to be used, and YARP will make regular requests to those endpoints to determine the server health. We can also do passive health checks. So as YARP is forwarding traffic to those servers, we will look at the response codes, and if there are server errors based on policy, we will mark those servers as unhealthy. So through destination enumeration, we look at all those destinations, we knock out the ones that are unhealthy, which then gives us a set of candidate destinations. Depending on the route configuration, there may be session affinity, which is enabling sticky sessions. So incoming traffic from a particular client will always go to the same server. And that's assigned on the first request. We look to see, is there a session header in there or a cookie? If so, we'll ensure that destination is available and eliminate it into just that one destination. Otherwise, we go through load balancing. We've got a number of load balancing algorithms in YARP. The one that we prefer and that is used by default is a power of two policy. What that does is it randomly selects two destinations from that list and then from the available destinations, and then uses the least loaded of those two. Scientific papers have been done on different algorithms, and that one has proved to actually be better than purely random, because purely random ends up with spikes on particular servers. Doing the random across two and then choosing least loaded balances that out much better. We have our passive health check module. As the request goes through, basically the request goes through and then back again, so that's why we're really looking at the response. We can do request transforms. So we can change the URL, we can change headers. We typically try not to mess with the body in YARP and just stream it, because once you mess with the body, you have to bring it into memory, and that significantly impacts the memory usage and therefore the capacity and load for YARP. But header transforms are super easy, super light. And then we go on to a forwarding component, and this will take the HTTP context, the extra data, forward the request onto a backend server, take the response, and send that back to the client. A key thing to note here with using YARP as a reverse proxy is there is not a direct connection between the incoming requests and the request to the backend server. Those are separate, so calls can come in on HTTP2 and go out on HTTP1. One side could be TLS, the other isn't. So there's a lot of indirection here that you can use for your specific benefits. So that's kind of the overall architecture of YARP. I said that YARP was highly customizable. So let's look at the extensibility points. We are a pipeline. So each of these individual steps is a module in YARP. You can go write your own modules and insert them in between any of these, or you can replace these modules with your own custom implementation if you want. For configuration, Ben will demo this in a minute, but he showed coming from a proxy config file. Instead, we have a config provider model. So rather than if you're something like app service where you need to be fully dynamic, rather than loading data from a config file, you can go talk to a backend server, pull in that information, and just build up the structure in memory and then hand that to YARP. Health checks, we have a policy there that you can replace. Session affinity. I'm not expecting you to remember all of these. It's kind of giving you the overall impression that each individual component in YARP is customizable and replaceable, normally through an interface. So session affinity, we have load balancing policies. There's a number built in. You can add your own. There's a passive health check policy. You can customize that. Request transforms will go into in more detail. You can create your own. We have a whole library of them. And if none of that suits your needs, you can use the HTTP forwarder directly. So one of the most common areas people make requests on us, and that is configuration extensibility. And so by default, we read from app settings.json, but instead you can provide the configuration data to us directly as a series of in-memory objects. And to do that, you create your own class and you implement iProxyConfig. That just requires a collection of routes, a collection of clusters, and a change token that you can fire to tell us to go and re-request the routes and cluster data. And that's it. We have an in-memory provider that makes this simpler, and I will pass over to Benjamin to demo this.
Okay, so in this demo, I translated the appsetting.json settings file to use the in-memory in C#. So you can see. Basically, I just need a list of routes and a list of clusters. I configure my red route just like in JSON, but here it's in C#. Same with the blue route. Same deal with the cluster config. Here I have the red cluster with only one destination to 5002. And then instead of saying to YARP, hey, load the config from the file, I say load it from memory. Here is my list of routes, and here is my list of cluster config. So now if I go back here and start the app again, okay, it started. It should be same as before. I always hit red, and here I always hit blue. But as Sam said, one of the benefits of the in-memory config is that you can change it on the fly. So let's add a basic method that you should protect, of course, but in this demo, it's not protected, that will expose a small admin endpoint, a small admin method to change this config. So sorry, it's here. So let's add a get method. So every time you call this method, we want to change the cluster that the red path will be using. So for that, it's very easy. I will basically recreate my list of routes. I don't touch my blue route, so it will always stay the same. But for the red one, I will change the destination cluster here. And from there, I update the config by just calling update, sorry, and YARP will automatically refresh. Oh, yeah, by the way, I forgot to say, this is the component that YARP is using when you say load from memory to read the config. So you can get it from DI. Here I use minimal API, but this will come from DI. So with this object, I can call update with my new routes and my cluster, and it should update the config. So let's try it. So let's recompile it. Okay, it started. So let's go back to our header. Let's check that I'm not cheating. So red always return red. So now let's call my, my admin API. And let's say now I want the red cluster to be redirected to the blue cluster. Sorry, double slash. Okay, it should have worked. Now if I call this this method, it should return blue, and yeah, it returned blue. So yeah, here we can see that we can do, it's very easy using the in-memory config provider to change it on the fly. You can have multiple scenarios like reading from a queue, reading from an external services, etc. And that's it for now.
Yeah, this is also showing how YARP is just middleware, so you can mix the middleware of the map reverse proxy call with any other API calls you want on that endpoint. The YARP routes just end up being yet more endpoints exposed by that server. So you can mix and match with any other ASP.NET functionality as you want. Cool. So let's switch back. So that was configuration. Another area people want to make customization is request and response transforms. So these enable you to customize typically the headers on the way through the proxy and on the way back. So there's a list here of some standard transforms. We actually implement way more than these, but I didn't have space in the slides to include them all. So for instance, you can customize the path, modifying the URL. You can use regular expressions to change the URL. We can add query parameters. We can add additional headers. We can replace headers. We can modify headers. We can choose certs. X-forwarded is a standard set of headers supported by proxies or normally used by proxies to tell the destination that the request is being proxied, and here was the information about the original client request. So this enables the backend to know, even if you're going to a different URL at the back end, what URL the client had originally requested. And so up till now, those have all been kind of transforms on the forward end. We also have response transforms that enable you to customize the response going back to the client from the backend server. So again, we can add headers there, modify URLs, trailers, add whatever we need. And these are all relatively easy. You can just do it through middleware. And I will pass over to Ben again to demonstrate adding a custom transform.
Okay, so we are back in our small YARP example where we load the config from memory. Let's add some transform. So it's very easy. And let's start by removing the prefix. If you were attentive enough, you see that when I call red, I pass the red path to the API. Maybe we don't want that. So let's remove it. So basically what that says that every time you have the /red prefix, remove it. So if we try again, quickly, back here, started. Now I don't have this prefix anymore. We can also add a header. Let's add a header for the request. Let's recompile, relaunch. Okay, and here you will see a new header called my header. There, it was just added. And as you can see, like Sam said before, we have a set of standard X-forwarded headers that are common to most proxy workflow.
Great. So wrapping up, hopefully that's been a really good introduction to YARP. Some calls to action. We'd love to know if you're using YARP. You can drop us a note on the email listed here, or please come talk to us on GitHub. Welcome issues and discussions there. We welcome PRs from internal, external customers. If you're thinking about making a larger change, I'd strongly suggest you kind of ping us first, and we'll organize an online design meeting. We found it usually much easier to coordinate on the design before some code's written rather than after someone's trying to submit a change. But we've taken, and we do take a number of external changes. The YARP project is ongoing. We'll continue to do more releases. A couple of things here listed, but I think we're out of time. So I will wrap up and say thank you very much. And just to close, here's a link to the YARP package and the repo on GitHub. Thank you.